Geometry, Chapter 1, Section 8, Space Geometry. Space is the set of all points. Unlike one-dimensional lines and two-dimensional planes, space cannot be contained in a flat surface. Space is three-dimensional, or 3D. So all three of these objects that are here are three-dimensional objects that are represented in two-dimensional space. Isometric drawing is a particular way that uses a dot pattern so a 3D object can be represented on 2D. The object will have three visible sides, and the rest of the sides we can't see if this was a real object, and we use the dotted lines to represent the sides that we can't see. So the sides that we can see this side, we can see this side, and then we can see this top here. Those are the sides that we can see. This bottom part we couldn't visibly see. That's why you have some of the sides are represented with dots. This back side you can't see, and same thing with this back side. You wouldn't be able to see those. So the dotted lines help us represent what we can't see because it's behind the other objects. So let's draw a little bit more complicated design here. So here we have this object. I'm going to first draw this side and then this side. So I'm going to draw that front side like this. And then that other side, we go up here. So we went 6 for here, and I went 5 there. I kind of chose those arbitrary. I'm trying to make it look as close as I can to the original drawing. Now, I'm going to draw these pieces that are going up. So that first one goes up 4. This one goes up half of that. This one goes up half of that. Now, let's connect them and make this square here. So I connect those. Now you'll notice those are the same length, and then these two are also the same length. All right, let's continue this pattern. I'm going to have it go up, over, up, and then over again. Now you'll notice that those two lengths are the same total length as that. So I'll do half of it, go up, and do half of it again. Now let's connect that. You'll notice this ends up being the same length as that. Now let's connect those two segments. Okay, so we've got the front side of it. Now we need to make the back side, the side that we can't see. So I'm going to do that in a dotted line here. Okay, so I'm going to start from down here. And then let's make this one. Connect those. Connect that going up. And there is our completed shape. A net. A net is a two-dimensional pattern that you can cut and fold to form a three-dimensional figure. Now, what we have here as a net is a shape that we could fold in creating a cube. So this side here, I could fold up. This I could fold up. This one I could fold up. This one I could fold up. So this, 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 and this all become the sides. This is the bottom, and then when I fold this up as well, it becomes the top, and it creates a cube shape. Well, not all nets can be folded such that they create a valid shape. This particular one, while it has 6 sides to it, I can't create a cube from it. Because what happens is this is the bottom, this becomes a side. I'm not actually going to make something that will be the side here, because this gets flipped up, becomes a side. This gets flipped up, it becomes the top. This gets flipped up, becomes another side, so it's all the way, this guy gets wrapped all the way around, so he's right here on this side. And then this guy gets folded again, and he actually ends up being the bottom. He ends up getting folded all the way to the bottom. So that could not create a cube. So let's do a little bit of algebra review. Let's simplify this problem here. So we have x to the third, y to the fourth, all of that divided by x squared, y to the seventh. So when we're dividing, let's think about this. X cubed over x squared, that's the same as this. X times x times x divided by x times x. Well, you're left with just a single x. Well, another way to think about that would be x to the third minus whatever you're dividing it by, which was 2. So I'm left with x to the 1. I don't need to write the 1. Now I have y to the fourth divided by y to the seventh. So that's y to the 4 minus 7, which is y to the negative 3. Well, we want to make sure that our exponents are positive, so a negative 3 is written as a positive 3, but now you're doing division. So x divided by y cubed. So a little bit more complicated one. 4x to the fourth, y to the fifth, 7 to the negative 3. 6x to the third, y to the negative 7th, z to the 5th. Okay, so 4 divided by 6, I'm going to reduce that to 2/3. X to the fourth, so divided by x to the cube, so 4 minus 3, that leaves us just x. Y to the fifth minus negative 7, well, that's plus, so 5 plus 7 is y to the 12. Z, negative 3 minus 5, that's z to the negative 8th. So negative, as an exponent, I want on the denominator, so I'm going to have z positive 8. So my negative 8 becomes a positive 8 on the denominator. And that is the end of our lesson.